Alright, hello again, everybody. We should hopefully have been in our seats and have something down for our do now. If you do not, however, please take that time and go ahead and start your do now. You have 3 questions on your do now. So take about 4.5 minutes. Take 4.5 minutes, get through these 3 questions. Silent and solo, please begin. Go ahead and pause the video here. Alright. So, quickly going through these, we're going to look at number 1 and number 2. So number 1 says that given the lines y equals 2x plus 1 and y equals negative 0.5x plus 4, are the lines parallel, perpendicular, or neither? Well, let's take a look. So remember that for parallel, we have that m1 is going to equal m2. So I know that the first slope should be equal to the second slope, and hopefully we should right away see that that is absolutely not going to be the case here. 2 is not equal to negative 0.5. And so because of that, we know that these lines are not parallel. So boom, we can go ahead and cross that off right away. If we're looking and seeing if they're perpendicular, it's actually going to benefit us just because of how we wrote this out. Remember that the way we wrote it is that if these lines are perpendicular, the slope of my second line should be the negative version of the reciprocal of my first line. So it's going to be the opposite reciprocal of my first line. And so because of that, we're actually going to take this 0.5 and we're going to write it out ever so slightly different, because we know that, hey, if I have negative 0.5, I really have negative 1 over 2, and that's going to be, right now, my m2. So let's take a look. So again, in order for this to be perpendicular, this m2 is going to have to be negative 1 over, and then my m1, as we discussed over here, is this 2 value. So it should be negative 1 over 2. And if I look up here, hey, that's exactly what I wrote when I changed this into a fraction from a decimal. And so in fact, looking at these two, I know that they are in fact perpendicular. These two lines are perpendicular because they are going to be negative reciprocals when we're looking at our slopes. And a reminder too that perpendicular means that we're crossing at a 90-degree angle. I know it's something that we've written before, but just as a refresher, it's when we cross at a 90-degree angle. So moving down to number 2, we're told that line L passes through the points negative 2, 3, and 3, 13. And we want to identify the y-intercept of line L. Now this is something we have definitely done before. First thing I need to do here is I need to figure out my slope, right? Because I need to figure out the rate of change before I'm able to do or manipulate these in any sort of way. So first thing I'm going to do is I'm going to label my points. So I have x1, y1, x2, and y2. I'm going to go ahead and set this up. I know that m is equal to y2, so 13, minus y1, which is 3. And that's going to be put over x2, so 3, minus x1, which is negative 2. So this is really going to give me 10, because 13 minus 3 is 10, over. Remember that subtracting a negative is the same thing as adding. These two cancel to be positive. So this is really going to be 3 plus 2. So we're going to have 10 over 5, which when we reduce this is 2. So I know that my slope is 2, and I have a few different ways that I can actually go about this, right? First one would be to say, hey, if I know that my slope is 2 and then I have a point, I know that I can actually write this as y minus 3 is equal to 2 times x plus 2. Remember, this is a plus because this is a negative. And then go ahead and solve and put this into y equals what have you. Or, alternatively, I can actually just make a table, right? Because I have this negative 2 value for my x's. And I know that corresponding y value is 3. I know that my slope is 2, so if I then go to negative 1, I'm adding 2 to jump from here to here. So this is going to put me at 5. And again, adding 2 to make this jump here. And so my y-intercept, or where my x-coordinate is 0, is going to be 7. So now that my y-intercept, if you had just written 7, remember that that is incorrect. Our y-intercept should always be some sort of coordinate point, right? We should have something and something. So my y-intercept is going to be 0, 7. All right, take a second. Make sure you have these down. And once you have these down, we're going to switch to our notebooks. So get these down and make sure notebooks are out. You can go ahead and pause here and play when everybody has notebooks out. All right, so we all have notebooks out. We should all have dates up at the top. I want you to go ahead and write down example 1 in your notebook. Do not worry about writing down example 2. We are simply looking at example 1 right now. And example 1 says that line K passes through the points -3, 4, and 1, 5. We need to write a possible equation of line L that is perpendicular to line K. So go ahead and make sure that you have this down. I'm going to ask that the video get paused, and then once everyone has this down, you can go ahead and play again. All right, so everyone should have this down. And so I'm looking for, really what I'm being asked here is to write a possible equation of line L that's perpendicular to line K. But in order to know that, I need to know what line K is. So for line K, we know that we're passing through the points -3 and 4. And 1, 5, right? These are our lovely 2 points that we're working with here. For this, again, as we know and as we have done plenty of times before, I gotta find a slope. I'm gonna quickly label my points, x1, y1, x2, y2. That is a y. So my slope is going to be 5 minus 4 over 1 minus a -3. This is going to give me 1 over, remember, this is actually going to turn into 1 plus 3. It's going to turn into 1/4. So now my slope 1 is 1/4. Awesome. And remember that when we're looking at perpendicular, actually, you know what? Getting a little bit ahead of ourselves. For now, let's just continue making line K. So I have my slope for line K. We can use any form we want here, but easiest thing is going to be we have a point, we have a slope, point, slope. Boom. I'm going to have that y minus 4 is equal to 1/4 x plus 3. And remember, because this is negative here, this sign has to change to a positive. So this here, this is line K, right? So that's line K. Now I want to know what is line L, and line L is perpendicular to line K. So remember that when we're looking at perpendicular slopes, the second slope, or sorry, perpendicular lines, the second slope should always be equal to the opposite reciprocal of the first slope. And so mathematically, again, that's what that looks like. So if m1 is equal to 1/4, if I were to change this to its reciprocal, we should all hopefully be able to say, like, hey, the reciprocal of 1/4 we know by now is 4. And if I want the opposite, so if I want that negative, it's going to be -4, right? Because we're simply taking the reciprocal and changing the sign. That's really all this is saying. So because of that, I know that m1 is equal to this, absolutely. So that means that this value here is actually going to be m2. So the slope of my second line is going to be -4. And so from here, I can choose any value at all. We actually don't have to worry about what form we put this in, as long as we can easily show that our slope is -4, because it's okay for perpendicular lines to have the same y-intercept. With parallel lines, it's something we avoid because it shows that we have the same line, but because we inherently have different slopes, we know that we're going to be guaranteed different lines here. So I could in fact just say, hey, the perpendicular line is going to be y-4 equal to -4, x plus 3. I can use the exact same point and say, I know exactly that they're going to cross at this point here, because that's really what that would be saying. I could have also said that, hey, y is going to be equal to -4x plus 1 minus 2, just -4x. As long as you have that -4 in there, you've got it. And we know that this or these are possible equations for line L. So again, when we're looking for perpendicular, we're honestly just looking to have the second slope be the reciprocal with a different sign. The opposite reciprocal. All right, make sure you have this down. As soon as everyone has this down, we're going to move on. But for now, pause it here. Make sure we have it down. When we all do, we can come together. All right, so we're actually going to go to problem set A. Problem set A is only 3 questions. We're actually going to work through all 3 of these. So for problem set A, you're going to work through 1, 2, and 3. You're going to have 6 minutes, and for problem set A, we're going to be silent and solo. Go ahead and begin. You can go ahead and pause it here. All right, so those 6 minutes have passed. Hopefully you've gotten most of the way through these. Really what we're doing today, if you haven't noticed, is just making sure that we're having practice with both parallel and perpendicular lines, because these would be something that should come really quickly to us now. Where like, if you're looking at a slope and I say what is a parallel slope, you should be able to know, hey, it's going to be that same value. And if we're looking at a slope and I want to know the perpendicular slope, we should be able to say, hey, it's going to be the opposite reciprocal. And so we're looking for these to be kind of just like really quick hits here. So for number 1, we have that line 1 passes through the point 9, -4, and 3, 2. Line 2 is parallel to line 1 and contains the point 5, -2. And we need to write the equation for line 2. Now, we're going to mention it again, and we're going to see it again. Line 2 is going to be super specific, right? Because they've actually given us a point. And so it's not just going to be some willy-nilly line like we've seen previously in all of our past examples. But in order to start, I need to find the slope of line 1. That's step 1. So this slope here is going to be equal. So this is my x1, this is my y1, this is x2, this is y2. My slope, there we go, slope is going to be 2 minus a -4 over 3 minus 9. This is going to turn into 2 plus 4. So I'm going to have 6. And then underneath, 3 minus 9 is actually going to be a -6. And so 6 over -6 is going to give me a -1. And so I know that the slope for line 1 is a -1. And remember that when we have parallel is really saying that, hey, M1 is going to be equal to M2. And so I know that it stands. And so these 3 dots you might see more of as we move forward. If you ever see those 3 dots like that, that actually means therefore, right? So what that means is, hey, M1 is equal to -1, therefore M2 is equal to -1, right? Because those are the rules of parallel lines. And so to write line 2, I have my slope, perfect, but I also have a super specific point. So I have slope and point slope form. That's all I'm going to have to do. So I'm going to have that y plus 2 is equal to a negative x minus 5. And again, this is a -2 here, so this needs to become a positive. But this is our line. Coming down, we're actually going to bypass 2, and we're going to talk about number 3. So So for number 3, we have that a line M is perpendicular to the line y is equal to 3x plus 4 and passes through the origin. Write an equation of line M. Alright, so this is super similar to number 1. Instead of going parallel, we're actually going perpendicular this time though. So we have slope 1. Slope 1 is 3. And so when we're thinking about what is the negative reciprocal of 3, we're going to have negative 1 over 3, right? Makes sense. Super simple. Nice and easy. So boom, I already have the slope of my second line. And now just as above, they also give us a specific point that this needs to pass through. They're just a little bit sneakier about it. And by that I mean that they say that it goes through the origin, but we need to make sure that we remember that the origin is in fact 0, 0. So that's the point that it needs to go through. And so we have a few ways of doing this. If you rather put, hey, y minus 0 is equal to negative 1 over 3 x minus 0, you can do that. I just ask that once you have this, you do simplify and see that, hey, this is actually going to become y is equal to negative 1/3 x. Because really that b value is 0, which we see represented below. So go ahead, make sure you have 1 and 3 down and correct. If you have questions on 2, whoever's filling in for me does have an answer key and will be able to give you the quick hit of exactly which one it is and show the work there if you would like. But go ahead and make sure you have these. You can go ahead and pause this video and then we'll come back together when everyone has this down. Alright, so we should be back together now. And we're going to move on to problem set B. Now for problem set B, we have actually a few problems. So for problem set B, we're going to work through as far as we can for problem set B. We're going to work for about a minute on our own, really dig into number 1 by yourself, see how far you can get, see if you can get the entire question in 1 minute. 1 minute, silent and solo, and then when that timer is up, we're going to move to partner work. So 1 minute, silent and solo. After that, we can open it up for partner work for someone who is next to you, and everybody should be staying in their seats for that partner work. Go ahead and begin. All right, so we should be back together. Hopefully you and your partner were able to make it through a decent amount of problem set B. But really quickly, I really want to go over number 1, and then I'm going to let you move on to your exit ticket just for the sake of time. So number 1 says that in the xy plane, the line y equals mx minus 8 is parallel to the line 2x plus 3y equal to 6. And we want to know, hey, what is that value of m? And so again, we want to see, well, what do we know about this line? We know this is parallel. So as we've written so many times before, we know that parallel means that slope 1 is going to be equal to slope 2. So slope 1 is that lovely m value where it's like, well, I don't know what it is, right? It's just saying what is m, and that's what I need to find. So looking at my second line, I have everything filled in. Perfect. If we didn't, this would be a much more difficult problem. But I need to take the second line here, and I need to find the slope. And then from there, I can start drawing conclusions. So I'm going to go ahead and subtract 2x from both sides of this equation. So I'm going to end up with 3y is equal to negative 2x plus 6. From there, I'm going to multiply both sides by 1/3. I'm going to distribute that 1/3 in. Remember, these will cancel out on my left, and that is by design. So I'm going to have that y is equal to negative 2 over 3x plus 6 times 1/3 is actually just going to give me 2, which is perfect, a nice whole number. So from here, I have my slope now, right? I have this negative 2/3 value. So I know that m2 is equal to negative 2 over 3. Therefore, it stands to reason that m has to be equal to negative 2/3, because these lines, as we said in the problem, are in fact parallel. All right, if you do have any other questions or need help with any of the other ones, again, whoever's filling in for me does have my key and can go over anything else that you want to see. But barring that, we're going to jump to our exit ticket. Your exit ticket is 2 questions. Your exit ticket is nice and short. Go ahead and go ahead and use what we've talked about today and possibly earlier this week or even earlier today for some classes, and work through this exit ticket. 2 questions. You have until the end of class, silent and solo. Please begin.